Hello, and today we're going to be talking about geometric series. So previously we talked about a geometric sequence going like this and so on, but now we're going to be talking about a geometric series. So now we're taking the sequence and we're summing all of the terms like this, right? So let's take a look at our formula for a geometric sequence. Tn equals a times r to the power of n minus 1. And now we're going to try and add them as a list of terms. So we have our first term a plus our second term a times r plus our second term a times r to the power of 2, and then our third term blah 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 all the way to a times r to the n minus 2 plus a times r to the n minus 1. Now we're going to get Sn, and we're going to our series, and we're going to times it by r. So now we have ar plus ar squared plus da 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 ar to the n minus 2 plus ar to the n minus 1, and then we're going to have plus ar to the n. So now we're going to get the difference of these two series. So we're going to subtract both of these together, and you'll find that these start cancelling, and what we're left with is a minus ar to the n. Okay, so what we're going to do is we're going to find the difference of these two series. So we're going to go Sn minus r Sn, and that'll give us a minus ar to the n. And now we're going to factorize both sides. So we're going to factor out our series Sn lots of 1 minus r equals, and we're going to factor out a on this side, so a lots of 1 minus r to the n. And now we're going to divide both sides, so now we're left with Sn is equal to a lots of 1 minus r to the n divided by 1 minus r. So there's one formula right there for series. This will give us our series for any geometric sequence, but there is an alternative way to do it, right? It's the opposite of what we just did. Instead of, we're going to subtract our first series rather than r times the series, and we'll get a slightly different result. So we get ar minus a. So now we're going to factor out our series again, and we're going to get r minus 1, and then we're going to factor out a again, and we're going to get r to the n minus 1, and now we're going to divide by both sides again, and we're going to get a lots of r to the n minus 1 divided by r minus 1. Now, both of these equations will give you the exact same answer. The only advantage of one over the other is what the r value is, right? So, this here is used when r is less than 1, right? Modulus r. And this one here is used for when r modulus r is greater than 1, greater than or equal to 1. So what this does is it's just cancelling out negatives. So if r was less than 1 here, we won't get a negative on our denominator here, and if r was greater than 1 here, we won't get a negative on the denominator again. So because we can't have some sort of negative sum from a positive rate, if that makes sense. So I'm going to do two examples, one where r is less than 1 and one where r is greater than 1. We'll start with r is greater than 1. So we have the series 2, 4, 8, 16, 32 onwards, and I want to sum just those terms there, those 5 terms. So series 5 equals our starting number, 2 lots of our rate, 2 to the power of 5, 32, minus 1, divided by our rate, 2 minus 1. That gives us 2 lots of 32 minus 1 becomes 31, 2 times 2, and that becomes 62. So that's our sum. That's our series up to 5 terms. So we're going to start with 1, and then we're going to halve. Here's our term, etc. Right, so Sn is going to equal to divided by a lots of 1 minus r to the n. So r is a half. I want to work out the first 3 terms just for argument's sake. So S3 is equal to our first term, 1 lots of 1 minus our rate, which is a half, to the power of 3 over 1 minus a half. We're going to get 1 over 2 divided by 1 minus 1/8. We're going to times both sides by, times it all by 2 over 2, so it's still 1, and we'll get 2 minus 1/4 divided by 1, so 2 minus 1/4, that's 1.75. So that was geometric series. If you have any questions, feel free to leave a comment or contact me on social media, and I'll try my best to answer them all. And I will see you in the next video.